procedure is pretty similar to other algorithm like how we have done. So only difference is instead of importing linear regression or logistic regression, here you are importing SVM module of sklearn. Okay, so first import all the libraries. Here we are importing NumPy and Matplot library because we are going to see some visualization. Then what we will do, your real task starts from here. So from sklearn we are importing, one second, from sklearn we are importing import data sets. So there are some built-in dataset available in sklearn for practice. So we are taking one of such inbuilt dataset present inside sklearn library, that is iris dataset. Okay, so let me introduce you to the iris dataset. Iris dataset has 150 records. There are four different columns present. Okay, one is your sepal length, sepal width, petal length and petal width. Okay, so there are four columns: sepal width, sepal length, petal length. Okay, and finally one target column, that is class. So based on these four columns, which category the iris plant will belong to, like iris setosa or iris, there are three classes you can see. So it is basically a three classification problem, right? It's not binary. There are three classes: iris setosa, versicolor, virginica. So there are the three target variables. Based on all these columns, we have to finally categorize one record to each any one of these classes. Okay, and there are how many such records? A total 150 records. This you can know by using, as we have used, right? DESCR method. Describe method will give you all the description, maximum, minimum, statistical summary of the data set you can get by using DESCR. Okay, now once we done with that, what we can do, so we will import the svc from sklearn. We are importing the svc module. Svc is nothing but support vector machine module. We are importing from scikit-learn. Okay, this is done. Then as I told you, like, you have to create an object of that particular method. So a model is nothing but instance, you can say one instance of svc method. So we are calling, once we imported, we are calling the svc method here and we are creating a instance of that class. Once it is done, then as I told you, we have to split the entire data set into training set and testing set. So we got our xtrain, xtest, ytrain, ytest. Okay, so how we are calling, we are by calling train test split. Again, it is a inbuilt method of sklearn using which we are splitting the dataset into training and testing. And then finally the procedure is exactly same for all algorithms. Okay, only what you need to understand, in real life scenario, applying machine learning techniques is very easy. Okay, where is the challenging part? Understanding where to use. Like I told you, few categories, like few points where you can use svm. So where you can use when you have high dimensional data, like where here, like we have only four columns, so it may not give me good result. But when it is very high dimensional data, let's say 50, 60, 70, and like so many high dimensional data, in that case if I apply svm, that will give me good result. Okay, this is one of the category. So again, no worries. Finally we are going to, in this machine learning class, we are going to read one method known as ensemble method. So ensemble method is a hybrid method where we will check which algorithm, particular algorithm, is giving us a very good result. So seeing on the performance, we will implement the particular algorithm. Okay, at the end of machine learning class, we are going to see ensemble method technique. As of now, it's pretty simple. First, you have to import, then you have to create an instance, then you have to split the data. Step number 3. Step number 4 is called the fit method. Model.fit xtrain ytrain. So it will do nothing but create the model. So model training is done here. Okay, model training is done using xtrain ytrain. We trained our model. Our model is ready now. So let's now test our model. So what we will call the predict method. Okay, which will help us to test our performance. Okay, so finally, what we will do, we will call the predict method here. You can see predict model.predict, and we are passing the xtest value. So xtest has all the columns except 20% of the data in xtest except the target values. So predicted are nothing but very similar concept, just as what we have seen in linear regression, right? So predicted is nothing but the predicted outcome for x test values. Corresponding x test value y column is predicted by the model. Now we have the real value present in y test, right? Now what we are calling, we are calling the accuracy score method by passing the expected and predicted. Expected is nothing but original value, predicted is nothing but predicted value uh, by the model. So we got the score as 1, which is pretty good. So by seeing the score we can see it is, one second, excuse me. Excuse me. Okay, so it is almost like 97.4% accuracy. Okay, so what it is predicting? It is predicting the, if we give the sepal length, sepal width, petal width, new value for sepal length, sepal width, petal width, the model is telling us, seeing the sepal length, petal length, it is telling us which class that particular iris plant will belong to. Okay, it is predicting a class for us. And if we want to see in real life, we have the original value where con- we are like comparing the original value with the predicted outcome. Okay, this is pretty similar as we have done. So finally what we have done, so there are different kinds of kernel techniques I have told you, right? Now that's we are so lucky that initially by default the kernel technique is, I think, RBF. If you don't pass anything, the by default method is RBF. When you fitting the model, no, you should pass the parameter. Here we have not passed any parameters. I believe by default is SBF, RBF. But uh, let's say you got only 60% accuracy. Here we are so lucky that we got very good accuracy. But let's say your accuracy has not meet with your threshold, and you want to customize your algorithm. What you can do? You can try with some other kernel technique instead of RBF. You can try with some other kind of techniques. So there are so many techniques like Gaussian radial function, SVC, polynomial, third degree kernel. You can go through all this theory, what kind of kernel techniques you have. So the different kinds, as I told you, polynomial kernel, RBF, linear SVC.